The purpose of the main guard statement here is to prevent the execution of the following two lines outside of this module. So, for example, if I were to execute this, you can see the two print statements do execute. But if I were to import this into another module, like this one, so I import in my module here into this, and then use the add function and print the results, do you think these two print statements will execute? Well, let's test this out. You can see that they don't, only this statement gets executed here. So, the main guard prevents the execution of the following statements. Now, if you don't have the main guard, for example, in module 2, we don't, and we have a print statement, then if I run this, as you can see, we do get the output. So what will happen when I import module 2 and run this? And as you can see, if I run this, that we get execution of the two print statements there. So the main guard's purpose is to prevent the execution of anything in the main function that you don't want to execute outside of this module directly. So the main guard statement could be used to test out the functions in a module without having to import them in. In Python, falsy values are a major concept. So if you have a user input request here, this will return an empty string. So you will basically get this. And you can check it for a falsy value by using the not operator. So if I run this and ask for a user input, and if I don't enter anything, you will get this line executed to say you didn't enter anything. So you're not checking if the string is empty like this. You're instead using the not keyword. And same would apply to other data types. So for example, here you've got 0 input. That is also a falsy value. So you can check it with the not keyword. And so is like non, false, empty list, tuple, empty dictionary. So if I run this, you can see the falsy values do output using the not keyword. So just remember the falsy values. Rounding numbers in Python such as 3.4, 3.7 can be really confusing because you don't know whether it will round up or round down. If you have an int function, it will basically truncate the decimal part. If you use the float division method, it will truncate the decimal part, but will still give you a float date type. If you use the round function, it will actually round according to the mathematical rule. So as you can see here, 3 and 4 returned for 3.4 and 3.7 accordingly. So you can see with the round with a decimal return, it will actually give you the original number back, and the date type will be of class float, whereas previously, when you don't return a decimal part, it'll be of class int because that's the data type that it returns. You can more precisely control the rounding by using the ceil and the floor function. So as you can see, ceil will actually always take it up and the floor will actually always round it down. And if I run this, as you can see, these are the outputs we get. Some of them are int date type, but others are of float date type. And you can, as a professional developer, you should use a good naming convention. So let's take an example. Pascal case should be used for class names. Constant name should be all in uppercase. Instance variables should refer to self.variable name. Snake case should be used for most variable names, as shown here. Private variable should have an underscore at the beginning. Strongly private variable should have 2 underscores at the beginning. And then you can access all these variables using the methods here. So you should not really access strongly private attributes because although they are strongly private, they are still accessible. And the way you access them is using the instance name and then underscore class name underscore strongly private. And as you can see here, if I run this, you can see even the strongly private variable is accessible, but you shouldn't really access it. But here's how to access it if you need to. In Python, you can check the data type of a variable using the isInstance function. This function lets you pass in a parameter of the data type that you're looking for, and it will simply return a true or false. So we have a situation here where we are passing isInstance our variable name and the type of data we're looking for. If it's of that type, you will get a true returned by this function. And same would apply for the other data types that you can see here, but you can also pass in multiple values to check against any of them. So if any are matched, it will return a true. And here, for example, you can see it's int and string. Of course, the int matches, so it simply returns a true. So it's not an AND condition. But here, we're just passing is the integer a string, it will return false. So if I run this, and as you can see, we go true, true, true for all of them because we're checking against the data types that are there. But we have a false for the last one because integer is not a string. So that's how this isInstance function works. In Python, you can use none to check if an object exists or not. You should use the is keyword here to check if the object is equal to none. You should not use double equal to check against none. Although it works, in other instances it doesn't. So if I run this, as you can see, both of them will return x is equal to none. So in this instance, both these options, this and is none, work. But in this situation, where you have a custom class, that custom class is overriding the equal method, this will not work. So here, this shouldn't return that it is true, because value here is none, and we're checking if that is equal to the object, but object is not none. So as you can see here, if I run this, you can see this is returned here, even though this is saying is it none, because this class is overriding the equal method. Python does not require you to declare the type of variable. So for example, you can just call your variable integer value. That does not mean that you're telling Python its type, it's just the name of the variable. But you sometimes need to know what type of variable it is. So for example, what type of value is contained within here. In order to do that, what you need to use is the type function, and within the function, you supply it the variable name, and it will print out the type of class that the variable is of. So for example, this is an int class. So if I run this here, you can see we get the outputs as shown here. So we can see the first one is int, then we've got a float because it's a decimal, and we've got a string, and we've got a list. Tuples are a great data structure in Python. You can use them to return multiple values from a function. So as you can see, this function over here returns name and age. This is returned as a tuple, name and age. So you separate a tuple by a comma and surround them in parentheses. Those are then assigned at the other end when the function gets called. You declare your two variables, name and age, where you want to store the values, separated by a comma, and you call the function. The function will return two values in a tuple format. Those would then be assigned accordingly here, and then you can print out the results. Remember, the order matters. So the name and age, if they were other way around, it would print the wrong result. So you need to declare them in the same order that the function returns values. Python does not require you to declare the type of variable. So for example, you can just call your variable integer value. That does not mean that you're telling Python its type, it's just the name of the variable. But you sometimes need to know what type of variable it is. So for example, what type of value is contained within here. In order to do that, what you need to use is the type function, and within the function, you supply it the variable name, and it will print out the type of class that the variable is of. So for example, this is an int class. So if I run this here, you can see we get the outputs as shown here. So we can see the first one is int, then we've got a float because it's a decimal, and we've got a string, and we've got a list. You can generate random passwords in Python using one line of code. The passwords can contain uppercase characters, lowercase characters, digits, as well as special characters like shown here. So let's go. This is how you do it. So in order for us to generate a random password, we need to import in two modules into our code. One which is string, which will enable us to pick uppercase, lowercase, and digits into our passwords. And the other module that we'll need is random. This again is to pick some random letters and numbers from the string module to enable us to generate the password. So we'll use the print function to show the output of the password, and we'll use the join function here. The join function is needed because the output from the random module will actually be a list of characters, so it will be like an array. So we need to join them back together into a string in order for the print function to print them, and actually to enable us to see the password in one go. We will use random.choices, which takes in two parameters. One, which is what character list or list of characters that we want to process. And the other one, and of course we are concatenating our digits. So it will have characters A, B, C, D, E, F, G, all the way to Z, and numbers 0 to 9. So 0, 1, 2, 3. And then we need to put in another parameter, which is number of characters needed. In this case, we've gone with a password length of 12. Now, if you don't supply k equals 12, then you will automatically just get one character back out of this function. So we want 12. When those 12 are returned, then we will get the following output. And as you can see here, we have now got the output here, which is the password that's been randomly generated that is 12 characters long. If we run this again, as you can see, we now have a different password, which is again random. Now, another thing you can do is actually add in special characters. And in order to do that, all you need to do is concatenate the special characters that the function picks from. So we will do string dot punctuation. So we'll do string dot punctuation to enable us to pick random characters. If I run this again, you'll see now we actually have special characters such as the hash symbol. And if I run this again, you will see that we have more special characters such as the question mark, the curly bracket, and we've got the exclamation mark here. So there you have it. Always name your functions and variables that are descriptive. So don't call them A, B, R, for example. Instead, give them names such as amount, exchange rate, converted amount. This will make much more sense to you when you come back and look at your code in 6 months' time, and it will also help other developers. Also, name your functions for the purpose they are. So, rather than calling something currency, call it convert. You can make your code faster to execute and easier to read. So we have an example here where we have a list of numbers in this variable called numbers, and we want to convert these numbers into squares. So for example, 3 multiplied by 3 would give 9. We want to store those within this variable, and this code is neither concise, neither it is fast to run, and it is harder to read. So how would we make our code concise, faster to run, and easier to read? We can use list compressions. Now previously square brackets were emptied, and where we have defined those is by appending the numbers into that list. But with list compressions, rather than doing it in two steps, declaring a for loop here and then appending the items to the list, you do it within the square brackets. So the very first thing that you do, what operation would you like to do? In this instance, we would like to multiply x by x. The next step is the for loop. So for x in numbers. So this is the iterable part, what we are iterating through. And before, we had to use the append method, but the append is not needed here because the results of this operation are implied and stored. You have a list of students that you are trying to sort. You need to create a function called getScore. This getScore function will take in a single student and return the second element. This is 0 based, so the second element is number 1 element, which is here. And then you need to call a sorted function. Sorted function basically takes in the list of students. This is a reference to this function. So this is an object that is being called here. It will take in a student and basically get called for each of the students that get passed to this from the sorted function. Another way to do this is using the lambda function. Using the lambda function, you don't have to define the function here, which is basically a lambda function, a function that doesn't have a name. So anonymized function, also known as, it will take in a student, and from that student, it will return the first element. So this part over here is actually matching to this part over here. So this is just taking a student and returning the first element. This function doesn't have a name, so it can't be called anywhere else. However, this function over here can be called anywhere else. So if I run this now, this is the output result that you get. So you can see with the sorted list, this is it. This is the original list. And of course, this one is using normal function. This one is using the lambda function. So you can see the outputs here. Make sure you use the correct hash function in Python. The hash function here, built into Python, will actually change every time you run this. That means in a different session. But the hash function that comes from the hash lib SHA-256 will give you the same value whether you run it today or day after or a year later. So let's prove this. So you can see here, I've got this value here and this value here for the SHA-256. If I run this again, and you can see here now this one has changed because it's using the hash function here, but the SHA-256 has not changed because it is the same every time you run it, no matter today or tomorrow. So just make sure you use the right hash function for what you're trying to do. Hash here is to prevent DDoS style attacks. Let's prove that Python uses hash caches. So we have a variable called name that has the value of ABC. Name2 variable also has the same value. Then we have a loop. In the loop, at step 5, we change the value of the name variable to ABC2. And then at step 8, we change the variable back to ABC. So then we print out the hash value. And for the last statement here, name2 has the same value as name variable. So both of these should have the same hashes. Let's prove that Python does use hash cache to retrieve the values that it has already generated. So if we run this, as you can see, it has a hash value of 57, and then at step 5, it changes it to 0, and then it changes it back to step 8 at 57, because at step 8, we change the value back to ABC, so it gets the same value that it had already generated. And for the name2 variable, as you can see, that matches 57, which is the hash that was generated here for ABC for the name variable. So you can see Python uses hash caches to retrieve the values that it had already generated for the hashes, and that makes the code run faster and optimized so it doesn't have to recalculate it every time.